Hello everyone, and welcome to my presentation on Introduction to Microservices Architecture. I'm Afnan Batahir, a master's student at Vishwakarma University. Today we are diving into microservices architecture, a modern software design pattern that powers platforms like Netflix and Amazon. Let's explore how it works and why it's become so popular. What are microservices? Content, definition, a style of architecture where applications are structured as a collection of small, independent services. Each service performs a specific business function. Contrast with monolith. Key characteristics bullet points independent services can be developed, deployed, and scaled independently. Scalability scale only the needed services. Resilience failure in one service doesn't crash. The whole system technology diversity use different languages or tools per service. These characteristics make microservices very appealing, especially for large or growing systems. Each part of a system is isolated, making troubleshooting, updates, and scaling easier. Architecture overview include diagram already discussed above, labels client right pointing arrow, API gateway right pointing arrow, microservices right pointing arrow, individual databases use arrows to show flow. This diagram shows the typical flow. The client sends requests through an API gateway which routes them to the appropriate microservice. Each service talks to its own database, ensuring data isolation and autonomy. Technology stack content languages Java, Node, JS, Python, Go, communication REST, APIs, gRPC, message queues, Kafka, RabbitMQ, containerization, Docker, orchestration, Kubernetes, monitoring, Prometheus, Grafana. Microservices are tech agnostic, but these are popular choices. Containerization is key in tools like Kubernetes. Help manage and scale services efficiently. Advantages points faster development and deployment, easier scaling and maintenance, better fault isolation, supports CI, CD and DevOps, flexibility to adopt new technologies. Microservices accelerate development and simplify scaling. They fit naturally into DevOps pipelines, enabling more frequent and reliable releases. Challenges points increased complexity in service communication requires strong DevOps culture. Data consistency can be hard to manage. Monitoring and debugging across services is harder despite a benefits. Microservices are not free of challenges, they demand better planning. Best practices suggestions use API gateway for centralized routing and security. Implement DevOps and CI. CD pipelines focus on observability, logs, metrics, tracing. Use service discovery and load balancing. Keep services loosely coupled. Success with microservices depends on following best practices. Observability, automation, and careful design are crucial to avoid turning a flexible architecture into a distributed mess. Real world example Netflix highlights Netflix moved to microservices to handle global scale uses. Hundreds of microservices. Each service can scale independently based on demand. Netflix is a textbook Example, their switch to microservices allowed them to innovate faster and handle billions of streaming requests reliably. Conclusion summary: microservices promote modularity, flexibility, and speed. They're ideal for large evolving applications, not a silver bullet. Require the right team, tools, and mindset to wrap up. Microservices are powerful but not perfect. With the right structure and tools, they can help you build scalable, robust systems. I hope this presentation was helpful to you. Thank you very much. Thank you.